Well, thank you for joining us. I'm going to look at the second part of this question. We've previously been asked to find the expected value of x and the variance of x based on a probability density function f of x. This question then says the value of each ornament in dollars. Now, these are certain glass ornaments. The proportion of impurities per ornament is random variable. Now, the value is based on this impurity level, which is 100 minus 1.5 times x. Now, if V is 100 minus 1.5x, what will happen to our expected value of V and our variance of V, which is what we want, and we need the variance of V to get the standard deviation? Well, let's have a look at our x's. Originally, it ranges from 0 to 1. Now, if you add 100, if you multiply each x by negative 1.5, 0 times 1.5 is 0. 1 times 1.5 is negative 1.5. So x will then range between negative 1.5 and 0. That's if we multiply them by 1.5. Notice what happens to our range. Here we have a range of, equal to 1, but here we have a range which is equivalent to 1.5, our range, because every score has been multiplied by 1.5. So each x multiplies by 1.5. Keep that in mind, because that will adjust our x squareds, that will adjust our variance. Now then, when we add 100, so we add 100, we move that entire group of numbers from down here to being, just put the group of numbers up here. We'll move it, add 100, so plus 100 to everything, it'll be to 98.5 to V to 100. So the value in dollars will range from $98.50 to $100. This is a very small range, and the range is still only 1.5 times our original range. So adding 100 did not change the variance, did not change the range, did not change the variance. But multiplying at 1.5 does change the variance. Adding 100 does change the mean. It does change the expected value of V, but it does not change the variance. So let's have a look at getting the mean. The expected value of the variance will be 100 minus 1.5 times the expected value of x, which is 100 minus 1.5 times 17 over 24. All right, do that calculation. And we get 98.9375, and that is the value, that is the expected, the mean value, all right? So the mean value will be 98.9375. The variance of V will be 100 minus 1.5 I'll just say I'll set this up a little differently. We'll say that is variance of x, and x, v, is 100 minus 1.5 times x. Now, the variance, adding 100 does not change the variance. Adding 100 does not change the variance. So let's take that 100 out. Okay, so it won't make any difference. That's just the variance of multiplying each x by 1.5. But what we have to remember is when we calculate variance, we use x squared. We use the mean squared. So when we square 1.15, that will become 2.25. So I'll just change that to 1.15 squared. 1.5 squared times the variance of x. All right. So here we go. The variance of x, the variance of x is going to equal 2.25. Variance of v is going to be 2.25 times the variance of x, which is 139 over 2880. All right, so you see we apply the normal rule for v, 100 minus 1.5 times our expected value of x, but for the variance we have to go 1.5 squared times the variance of x, and that is approximately 2.25 times 139 divided by 2880, and we get 0.010859375. Finally, we want the standard deviation, and the standard deviation is the square root. The standard deviation will be the square root of our variance. So when you get the square root of 0.10859375, you get, it's going to be irrational, square root, approximately, they didn't want decimal places, so I'll just put 0.3295356 ... All right, and that is the standard deviation. So just in recapping, our expected value of v was 100 minus 1.5 times our expected value of x. Our variance of v was 1.5 squared times our variance of x. So hopefully these little formulas will help you move directly from answers of A to the answers of B when they give you a formula that x undergoes certain transformations. Thank you for listening. I hope this has helped.